Alright, so when the pressure in the ventricle increases and the pressure in the atrium decreases, as the blood leaves the atrium and enters the ventricle, they're going to eventually meet. And once they do become equalized, that's going to cause that mitral valve to close. The mitral valve is the atrioventricular valve in the left side of the heart. The comparable valve in the right side of the heart is the tricuspid valve. So the mitral and tricuspid, excuse me, the mitral and tricuspid valve to closure is going to cause the S1 heart sound. Now, the mitral valve closure is going to allow for the pressure to increase in the ventricle. So this is going to be the start of isovolumetric contraction. Now I call it isovolumetric contraction. It's also called isovolumic contraction, but that's hard for me to say, so I just stick to isovolumetric contraction. Now, during isovolumetric contraction, there is no change in the volume of blood because no blood can enter or leave the ventricle. So because blood cannot enter or leave the ventricle, but the ventricle is contracting, so isovolumetric contraction, the pressure is going to increase very sharply until you reach a point where you meet and then exceed the pressure in the aorta. So here we have this gray line, which is the aortic pressure. So once you have met and exceeded the pressure in the vessel that is the aorta, you can open the doorway valve that is the aortic valve. So opening that aortic valve, you now have ventricular pressure that is greater than the aortic pressure. And now that your pressure is higher than the aortic pressure, the ventricular pressure is now higher than the aortic pressure, blood will flow from an area of high pressure to low pressure from the ventricle to the aorta. Now, this will cause a drop in volume in the ventricle and a decrease overall and a slow decline in the increase in pressure until you've reached peak pressure at about 120 millimeters of mercury. Now, this peak pressure during this ejection phase, and it's called the ejection phase because you're ejecting blood from the ventricle. This ejection phase is going to slowly decline in pressure as you lose blood from the ventricle until the point where you meet, where the pressure in the aorta is equal to the pressure in the ventricle, and that's going to allow the valve in the aorta to close. Now, when you have valves closing, they close with a sound. Now, this aortic valve closure and the comparable sound of the comparable valve is going to be the pulmonic valve in the right heart. So the aortic and pulmonic valve closing is going to be the second heart sound, the S2 heart sound. So that's going to be your dub. So now that's going to allow for the pressure to increase in the aorta, and this is going to be a diacrotic notch. That's going to be from the rebound of blood, but don't worry too much about that for Cambridge purposes. And then you're going to have the ventricle relax. And now that your aortic valve is closed and your mitral valve is still closed, both valves are closed again. So you're going to have isovolumetric relaxation. Your ventricle is relaxing, and no blood can enter or leave the ventricle. So you're going to have a sharp decrease in pressure until you reach the point where you meet and then go below the pressure in, once again, our atrium. So once the atrial pressure exceeds the ventricular pressure, our mitral valve can open again. So once our mitral valve opens, blood will flow in, and we'll have a rapid inflow phase of blood from the atria into the ventricle because, once again, our pressure is higher in the atria than in the ventricle. And this rapid inflow phase will fill about 70 to 80% of our blood, this rapid inflow phase. And then we'll have our diastasis period, where not much is happening. And this period is sort of like the pause in our heartbeat. Now, this diastasis period can be a variable length. This is fine. Then we'll have our atrial systole again. And then we'll have, once again, our mitral valve closure, then we'll have isovolumetric contraction, and then we'll have our ejection phase, and then we'll have our isovolumetric relaxation with our aortic valve closure, then our isovolumetric relaxation, and then our mitral valve opening, and then our rapid inflow. And then the cycle repeats over and over and over again. And this is how we get that heartbeat. Bum, bum. Bum, bum. Bum, bum. Bum, bum. All right? Now we're going to move down here. Now we're going to talk about this ventricular volume over here. This is the volume of blood inside the ventricle. Now remember what's happening here. This is where we were before. During diastole, we started off where we had about 80% of the volume of blood already. Then we had atrial systole, where 20% more of the blood came in. Then we had that isovolumetric contraction. Our volume of blood is staying the same, but our pressure is greatly increasing. Our pressure is rapidly rising, but our volume is staying the same. Then we had our ejection phase, where our pressure is peaking and then falling. Well, our volume is greatly declining and then bottoming out, because what do you know? Our blood is being ejected from the heart. Then we have this period of isovolumetric relaxation, where the ventricle is relaxing and the valves are both closed. So our volume is not changing. The volume of blood is not changing, but the ventricle is relaxing. Then we had this rapid inflow phase as our mitral valve opened and blood rushed in from the atrium. So we have rapid inflow of blood and our volume greatly increases. Then we have this diastasis where really not very much is changing. Then we have our atrial systole again. Now, and the cycle repeats. Let's take a look at our electrocardiogram. So our electrocardiogram is the electrical conduction in the heart, which we'll talk about later. This is going to be our, let's take a look at it over here. This is going to be our P wave. Our P wave is our atrial systole. This is our atrial contraction. So atrial systole is incited by atrial depolarization in the heart. This P wave precedes atrial systole. P wave precedes atrial systole. So this P wave causes the contraction of the atrium. P wave precedes this. So here we have the P wave, then the atrium contracts, causing this flow of blood into the ventricle. Then we have our QRS. Our QRS is ventricular systole. This is our ventricular depolarization. QRS goes very quickly, and that begins our contraction. That begins the contraction of our ventricle. So QRS fires, and then we have the contraction of the ventricle. Begins immediately after that. And it continues for a while. Then we'll have our T wave, which is ventricular repolarization. That will be the relaxation phase of our ventricle. So the relaxation is occurring during our T wave. So note these timings. These timings are very telling. So the electrical conduction precedes the muscular contraction. Electrical conduction precedes muscular contraction. Now, let's talk about the phono cardiogram. The phono cardiogram is the heart sounds. These valve closures, this mitral valve closes, and that causes S1, the first heart sound. Then the aortic valve closes, and that causes S2. So that's your lub and your dub. Lub dub, lub dub, lub dub. This third heart sound is part of the rapid inflow. That might be present in certain individuals. It's a normal variant, but it may not always occur. And that pretty much covers this image, so we're going to switch to another one. Now this is one cardiac cycle. This is pretty much what we just covered, showing all of our atrial systole, our left atrium, our left ventricle, our aorta. This is our diacrotic notch. This is our electrocardiogram with our heart sounds. This is all this stuff. But this is what's happening in the actual flow of blood. So during the ventricular filling phase, we have the atria filling the ventricles. And then during the atrial contraction, we have the remainder of the blood being forced into our ventricles. Then, during phase 2A, our ventricular systole, this is ventricular filling phase, by the way, mid to late diastole. Then we have the ventricular systole. Phase 2A is isovolumetric contraction. Then we have ventricular ejection. Ventricular ejection, the aortic and the pulmonic valves are open, and the blood is being ejected from the right and left ventricles into their corresponding great vessels, the arteries. Now we have phase 3, which is isovolumetric relaxation. And then back to phase 1, where we have ventricular filling once again. Now, the entire time that isovolumetric relaxation has been going on, the atria have been refilling from the veins of the pulmonic and systemic circulations. So that's ongoing as this entire process. Veins refilling the arteries, the atria of the heart, is an ongoing process, so long as the pressure is low enough for that to occur. And now we can return back to our previous format.